Never look directly at the sun. Why not? The sun causes eye damage in less than a second of staring at it. How does that happen? The sun emits light with an intensity of 1,000 watts per square meter. The light gets focused by your eye to a spot 160 micrometers in diameter with a power density of 90 milliwatts per square millimeter, which causes retinal cells to quickly disintegrate. For reference, here is a video of what different powers of lasers can do. These lasers have a beam cross-section of approximately 1 square millimeter, so the 100 milliwatt laser has approximately the same power density as sunlight on the retina. Is the sun really that powerful? Yes, the sun is extremely powerful. You can measure this with a quick experiment. Light a tea candle and put it in direct sunlight. You'll see that the sunlight reflecting off a white surface is brighter than the candle. A tea candle emits 1 candela of light in all directions. The flame of a tea candle has an area of approximately 1 centimeter by 5 millimeters. Thus, we can calculate the brightness or luminance to be 20,000 candela per square meter, or 20,000 nits. Due to the inverse square law, the luminance of sunlight on the surface of the Earth is equal to the luminance of sunlight on the surface of the sun, scaled by the square of the sun's radius divided by the distance of the Earth to the sun, multiplied by the reflectivity, 0 for Van de Black, 1 for spectralon, and the cosine of the angle of incidence. This rough calculation estimates the sun to be 1.3 billion nits, very close to the accepted value of 1.6 billion nits. This is brighter than any natural source of light except possibly for lightning. Note that there are unnatural sources of light that are brighter than the sun, including nuclear explosions and lasers. But a look at the sun every day, how can it be so dangerous? Accidentally looking at the sun is very different from staring at the sun. The blink reflex occurs in about 250 milliseconds of looking at a bright light. Head and eye movements during accidental exposure effectively spread out the image on the retina. Intentionally staring at the sun causes a single spot on the retina to be exposed, greatly increasing the risk of damage. The sun has 3 primary hazards to the eye: lens damage from ultraviolet radiation, photochemical retina damage from blue light, and thermal retina damage from visible and infrared light. Can I look at the sun during a solar eclipse? The moon changes the apparent shape of the sun, but doesn't change the sun's brightness. This reduces the retina thermal hazard, but the photochemical hazard is unchanged. Eclipse blindness happens to people who look at the sun during a partial or annular eclipse. It is only safe to look at the sun during a total eclipse, where the sun is fully obstructed by the moon. What makes an eclipse so dangerous? Everyone knows to avoid looking at the sun because it's painful. During an eclipse, people are inclined to look at the sun because it appears different from usual. This can cause prolonged sun exposure and eye damage. I'm going to look at the sun anyway. How long can I safely look at the sun? The International Commission on Non-Ionizing Radiation Protection publishes guidelines to prevent injuries from light sources. Using these guidelines in ASTM G173-03 standard tables for reference solar spectral irradiances, I calculated the maximum exposure time for each of the 3 primary hazards if staring directly at the sun. The worst of these hazards is the thermal retina hazard, which limit is exceeded after only 6 milliseconds at solar noon on a summer day in the contiguous United States. During a solar eclipse, the sun's obstruction decreases the thermal power on the retina and increases the retina thermal limit by the 4th power of the inverse obstruction percentage, where 50% obstruction would increase the retina thermal limit to 96 milliseconds. Even when the sun is nearly fully obstructed, the unobstructed areas are a photochemical retinal hazard. The photochemical retinal limit is exceeded after 0.9 seconds of looking at the sun, including during an eclipse. Can I look at the sun while wearing sunglasses? Sunglasses transmit about 20% of visible light, but also transmit as much as 90% of infrared light. If your pupils dilate from wearing the sunglasses, more infrared light will enter your eyes and negate the benefit of wearing sunglasses. Don't look at the sun without wearing ISO 12312-2 certified eclipse glasses. They can be purchased for just a few dollars and save you a lifetime of eye problems. Can I look at the sun through binoculars or a telescope while wearing eclipse glasses? Never do this. Binoculars and telescopes magnify the image of the sun, making it appear larger with the same brightness. This increases the irradiance proportional to the square of the magnification. Even if you wear eclipse glasses, the sun will rapidly melt a hole through the eclipse glasses and cause immediate permanent eye damage. Ensure that solar filters are used to attenuate sunlight before the sunlight is magnified. Is it safe to look at the sun through a pinhole? A pinhole reduces the aperture of the eye the same way a constricted pupil does. The average pupil is 2 millimeters in diameter when fully constricted. To achieve the same attenuation as eclipse glasses, the pupil would need to be reduced in area by a factor of 30,000. Therefore, a pinhole with a 10 micrometer diameter would be sufficient to look at the sun. A pinhole of this size can be purchased from a scientific optics supplier such as Thor Labs or Edmund Optics. Do not look directly at the sun through a homemade pinhole. The sun is extremely dangerous to look at, but with adequate protection can be amazing. Be safe out there. Never look directly at the sun.